Math is made easy, no more fear. Target online class, we got you. Wherever you want to from, we got what you need. Target online class.
Good day, viewers all over the world. You are welcome to Toydev online class. So today we want to look at probability with replacement. Of course, we've defined probability as the likelihood of an event happening. That is, and we have established the fact that probability lies between 0 and 1. Okay, so we've talked about mutually exclusive events, mutually inclusive events, dependent and independent events, addition law, multiplication law of probability. So we want to look at the effect when we have probability with replacement. We can also have probability without replacement. So let's start with this. So for the purpose of this course, we just want to concentrate on probability with replacement. So what is the implication when we are to find probability with replacement and without replacement? That is what we actually want to do this morning. So what is the implication of having probability with replacement and having probability without replacement? So probability without replacement. I'm going to use example to actually explain this. So let's see this example. A bag contains 5 blue balls, 6 red balls, and 4 green balls. So if three balls are chosen at random, okay, find the probability. If 3 balls are chosen at random with replacement, so the question now says that we should find the probability. We should find the probability that, okay, the first question, find the probability that we have, it is 2 red and 1 blue. So that's the first question. We want to find the probability that if 2 balls are chosen at random, it is 2 red and 1 blue. So let's see another. So the second question, that the three balls are 3 green balls. See that they are of the same color. They are of the same color. The last question is that they are of different colors. So I want us to understand this question very well. This question now is question under probability with replacement. A bag contains 5 blue balls, 6 red balls, and 4 green balls. So the question now states further that if 3 balls are chosen at random with replacement, find the probability, the first question, that the balls are 2 reds and 1 blue. We should find the probability that there are the 3 balls are 3 green. We also find the probability that they are of the same color. Then we should also find the probability that they are of different colors. So that's the question. That is the question. So how do we approach this problem? That is the question. Okay. We'll first list out what we are given. What are we given? How many blue balls do we have there? It's 5. How many red? Red is 6. Then green balls. Green is, we have 4. So what is the total number of balls there? The total number of balls there will be 15. That's the total probability. And that's the first thing that we have to do. So we must know the number of blue, number of green, number of red balls. Then these are the total number of balls. We now find the probability. What is the probability of blue ball? The probability of blue ball will be number of blue balls, 5 all over total 15. That is the probability of blue ball. What is the probability of red ball? The red balls will be 6 all over 15. Then what is the probability of green ball? That will be 4 all over 15. So that's the first step. So that's the first step towards solving this problem. So we now want to take the question one after the other. We're going to take the question one after the other. The first question says that if 3 balls are chosen as random with replacement simply means that when we pick the first ball, from the bag, and if that ball, we pick the first ball, and if we pick the first ball and that first ball is red, we will return the ball that we've picked before we take another one. That's the meaning of with replacement. But if it's without replacement, we pick the first ball from 15. We are left with 14. So by the time we are going to pick the second ball, we are picking from the remaining 14. But in this case now, if we first pick the first ball, let's say it's red, we are going to replace that ball before we pick the second ball. So that is the difference between probability with replacement and without replacement. But since we are discussing probability with replacement, then that is the approach that we are going to follow. So now let's see. Let's solve the question. The A part of the question. We want to find the probability that the 3 balls picked are 2 reds and 1 blue. 2 reds and 1 blue. So how do we take that? So for us to be able to get 2 red and 1 blue out of the 3 balls, there are 3 possibilities. Is that we pick red, blue. That is when we pick the first ball, it's red. When we pick the second ball, it is red. Then the last ball is blue. Or we pick red, blue, red. That is when you pick the first ball, it's red. When you pick the second, it's blue. Then when you pick the third, it's red. Or we pick blue, red, red. These are the 3 possibilities that we can actually get. These are the 3 possibilities. We can't get more than this because 3 balls are involved here. And out of the 3 balls, 2 must be red and only 1 blue. Then if you look at this very well, at the end of the day, we are still going to get the same thing because we are talking about probability with replacement here. If it is with replacement, it's still the same probability. Nothing changes. So I can just say this. I can just pick 3. I can just say this is 3 multiplied by any of this. I can say 3 multiplied by red, red, blue. I'm still on the safer side because the probability of this will be equal to the probability of this. It will be equal to the probability of this. Okay. Then what would that give me? That would be 3 into bracket. What is the probability of picking red balls? Red is 6 all over 15 multiplied by the other red ball is 6 all over 15 multiplied by the probability of picking blue balls is actually 5 all over 15. Because we have these balls without replacement, when I pick this first one, I must return this first one before I pick the second one. Then once I pick the second one, I must return it before I pick the third one. That is why nothing changes. Then we can do some cancellation and actually come to the final answer. So 3 here 1, 3 here 1, 3 here 5, 5 here 1, 5 here. So 3 here is 2, 3 here is 5, 3 here is 2, 3 here is 5. I will have 4 all over 25. So the probability of picking 2 red balls and 1 blue is 4/15. Then we go to the question, the second question, where we should find the probability that the 3 balls are green. So the 3 balls are green. Of course, there's nothing we want to do here. It's still the same thing. The probability that the 3 balls are green, it will just be, what's the probability of green ball? The probability of green ball is 4/15. It will just be 4/15 multiplied by 4/15 multiplied by 4/15. That is what you're going to get. And if you multiply everything there, you're going to have 64 all over 3,375. That would be the probability of picking all the 3 balls to be green. That's the probability of picking all the 3 balls to be green. Then the third question is to find the probability that all the 3 balls are of the same color. Probability of same color. Same color. That is, all the balls are same color. That simply means that the ball can be either green, or blue, or red. These are the possibilities. So if they have the same color, is that they are blue, green, or red. These are the possibilities. So when they are green, of course, we know what to do. When the balls are green, we are going to have, we have it to be 4/15 times 4/15 times 4/15, or simply means plus. When they are blue, what's the probability of blue balls? The probability of blue balls is actually 5. That's 5/15 multiplied by 5/15 multiplied by 5/15. We're able to do this because this probability is with replacement. So we're going to see the implication when we have without replacement in our next class. This will be 6/15 multiplied by 6/15 multiplied by 6/15. That's what you're going to get. Then from here, of course, we have actually gotten the value of this one. It will be 64 over 3,375. I think that's the second question. Plus, when we have 5, what is the implication here? Here 1, here 3, here 1, here 3, here 1, here 3. We're going to have 1/27 here, plus here 2, here 5, 3, 2, 3, 5, 2, 5. So we are going to have 8/125. That's what we are going to have there. That's what we are going to have there. So we can actually go ahead and take the LCM. We can actually go ahead and take the LCM. So if we take the LCM, what is the implication? If we take the LCM here, if we take the LCM here, we are going to have this to be 3375. 33, that's 3375. Okay. So if we take the LCM from here, you can actually go through the process. Because of our time, I can go ahead and write the final answer. But if you take the LCM and do some cancellation, at the end of the day, you are going to get 9/75 as the probability when the balls are of the same color. So that's what we are going to get. Then if they are of different colors, what is the implication? If they are of different colors, same color. So the next question now, which is the last question, is that what is the probability of taking the 3 balls if they are of different color? What is the implication? So if they are of different colors, then probability has to do with the arrange. We have to arrange it. So if they are of different colors, we are going to have either blue, red, green, or blue, green, red, or we have taken blue as the green, red, blue, or green, blue, red, or now the starting point will now be red, blue, green, or red, green, blue. These are the possibilities. But since we are dealing with probability with replacement, we can actually take any of this. We can take any of this. because we are going to get the same probability. Each time, whatever we do, we still go, we are going to get the same probability. Okay, that's what I'm trying to say. So it simply means that I can say 6 multiplied by any of this. It's still the same thing. I can say 6 multiplied by any of this. Either blue, red, green, or blue, green, red, or green, red, blue, red, green, blue, red. We get the same, we are going to get the same answer at each of these. So I can say 6 multiplied by, let me just pick any of these, maybe blue, red, green. So my final answer will now be 6 multiplied by, what is the probability of blue? The probability of blue is 5 all over 15 multiplied by, the probability of red is 6 all over 15 multiplied by 4 all over 15. And that's what we are trying to say. So 5 here 1, 5 here will actually be 3. 3 here 2, 3 here will be 5. Okay, so 6 here, 3 here 1, 3 here will actually be 2. That will be 2. Then if you multiply everything, we have 2 times 2, 4 times 4, 16. 5 times 15, 75. So the probability of choosing different colors will actually be 16 all over 75. And that is what we are going to get. So I would love to stop here because of our time. In this case now, we actually we deal with probability with replacement. That is when you pick, you replace before you take the next one. So that is that about probability with replacement. In our next video, we'll come up with probability without replacement using the same question, so that we will know the effect or the implication of with replacement and without replacement. Thank you, and God bless you all.
Mathematics made easy, no more fear. Target online class.